Hello everyone, this is the second part of moment of a 3D force about a point and about an inclined axis, or part 2. So we have levels 11 to 15 here, and if we can apply scalar approach then we can, but mostly if we can have vector approach then we will do the vector approach. So here is level 11 problem. The force F acts along an element of the right circular cone as shown. Determine the equivalent force couple system at point O. So that's the force. The force acts on the z-axis, so therefore it has no moment about the z-axis. The radius of the cone at the base is h over 2 as shown in the figure, and the altitude is h. This is a right triangle, and the hypotenuse is the line of action of F. So therefore, we first solve for this projection of F on the xy plane. Let's call that fxy, and fxy is equal to magnitude of F times component of distance, which is h over 2 divided by distance, which is square root of h over 2 square plus h square. So magnitude of F, component of distance h over 2, the radius of the base, divided by the hypotenuse, which is square root of h over 2 square, this one, plus h square. So simplifying, fxy is equal to f over square root of 5. Then this is fx in this direction. It is adjacent to theta. Therefore, fx is fxy, f over square root of 5 times cosine of theta. Then fy is in that direction, opposite of theta. So it is fxy, f over square root of 5 times sine of theta. So that is fy. While fz, which is going down, is simply f times h divided by square root of h over 2 square plus h square. So this is the component of distance. So fh, and it is going down, so this negative fh over square root of h over 2 square plus h square, the hypotenuse. So fz is negative 2f over square root of 5. Therefore, the force cannot be expressed as a vector. The force at O would be f over square root of 5 cosine of theta I plus f over square root of 5 sine theta j minus 2f over square root of 5 k, or factoring out f over square root of 5, then we have f square root of 5 quantity cosine theta I plus sine theta j minus 2k. So that's the force. And let's proceed the couple. Let's have the components at the apex of the cone. So this is fx, fy, then fz. So MOX, let's evaluate MOX first. Your right thumb would be on the positive x-axis. The curling of your forefingers would be in that sense. So this is the positive moment. Fx has no moment because it is parallel. Fz, no moment because it passes through OX. Only this Fy component. But the positive sense of moment is in that sense. This moment of Fy is in the opposite sense, so therefore it is negative f over square root of 5 sine theta moment arm h. So MOX is negative f over square root of 5 sine theta times h. MOY, your right thumb here, the positive sense of moment is in this sense. So 0 because it is parallel. It passes through OY, so no moment. Only this component of force has moment about OY. And the positive sense is in this direction. If your right thumb is here, the curling of your forefingers would be in this sense, which is the same sense as the moment of this fx here. So therefore, it is positive. MOY is f cosine theta over square root of 5 times h. Then MOZ is 0, as mentioned earlier, because f passes through z. So in vector form, factoring out fh over square root of 5, then we have MO equals fh over square root of 5 times negative sine theta I, this one, then plus cosine theta j. So that's it. That's the force couple system at O equivalent to this force here. Level 12, a mechanic uses a crowfoot wrench to loosen a bolt at C. The mechanic holds the socket wrench handle at points A and B and applies forces at these points. Knowing that these forces are equivalent to a force couple system at C consisting of the force at C negative 8I plus 4K pounds and the couple M sub C 360 pound inch I, determine the forces applied at A and at B when A sub Z is 2 pounds. So this is the figure. AZ is 2 pounds, the only given component of forces at A and B. But we will use this information. First, negative 8, that's the force, equivalent force at C. So negative 8 is equal to AX plus BX. So CX is negative 8 and that is equal to AX going to the positive x-axis plus BX. Then CY is 0, there's no Y component there, and that is equal to AY plus BY. CY equals 0 equals AY plus BY, therefore BY is equal to negative of AY from this equation. Then CZ is 4 pounds and it is equal to AZ, which is 2 plus BZ. AZ is 2 given. So 4 pounds CZ equals AZ plus BZ from the figure. So BZ can now be answered. It is equal to 2 pounds. Then moment at CX, this is CX because 360 pound inch I is 360. So MCX is 360 and that's the moment about the x-axis. So if your right thumb is towards the positive x-axis, it is BY times 2. This is positive. The other components, BX and BZ, will have no moment. BZ passes through the x-axis, same level. BX is parallel to. Then AZ is also passing through the x-axis, so no moment. AX is parallel to the x-axis, so no moment. So BZ times 2, then because this is the positive sense of movement about the x-axis, CX-axis, then minus BY times 2 rather, then minus AY times 10 minus 2, so the moment arm of AY is about the x-axis is 8 inches. But because BY is negative AY, so 360 equals negative AY times 2 minus AY times 8. Therefore, AY is negative 36 pounds. So if AY is negative 36, BY is negative of negative 36, so BY is positive 36 pounds. Then moment about y-axis, CY is 0. And 0 is equal to positive sense of moment is in this direction. That direction because your right thumb is on the y-axis. The curling of your forefingers will be in that sense. So it is AX positive, same sense, and moment arm is 8. Then BX is minus times 2. Again, AX times 8. The moment arm is 8. That's 8 inches if this is imagined as the y-axis. Then minus BX times 2. Then minus, because this is the positive sense of movement, then minus AZ times 8 inches minus BZ times 8 inches also. Then, of course, BY and AY are not involved. They are parallel to the y-axis. So substituting the value of AZ, which is 2, and BZ, which is also 2. So 0 equals 8AX minus 2BX minus 2 times 8 minus 2 times 8. So therefore, and substituting the value of bx, which is negative 8 minus ax from this equation. So 8ax minus 2bx equals 32, 16 plus 16. Replacing bx by negative 8 minus ax, which is this from this equation here, equals 32. So 32 minus 16 is 16. Then 8ax plus 2x is 10. 16 over 10 is 1.6. So ax is 1.6 pounds. Then bx is negative 8 minus 1.6, negative 9.6 pounds. So therefore, we now answer the forces at A in vector form 1.6, quantity 1.6i minus 36j, then plus 2k pounds because AZ is given. While at B, the force at B is negative 9.6i plus 36j plus 2k pounds also. So that's it. Level 13. A couple M of magnitude 80 Newton meter is applied to the handle of a screwdriver to tighten a screw into a block of wood. Determine the magnitudes of the two smallest horizontal forces that are equivalent to M if they are applied at A, corners A and D, B at corners B and C, and anywhere on the block. So remember, the objective is to minimize or smallest horizontal forces equivalent to this couple. So if the forces, equal forces, opposite in directions, are to be applied at A and D, then the force at A would be in that direction, and the force at D would be in the opposite direction. And the perpendicular distance is 0.24. Therefore, P sub A times 0.24 meter equals 18 Newton meter. Again, P sub A times 0.24, that's 0.24 meter equals 18. So we can now compute P sub A, which is equal to P sub D, but they are opposite, 75 newtons. Then for B at corners B and C, to minimize the forces, then the force at P would be in that direction perpendicular to BC, and the force at C should be in the opposite direction, also perpendicular to BC, so that these forces will be smallest as possible horizontal. So this distance BC is, imagine a right triangle, this component is 0.32 minus 0.24 quantity square, and this one is 0.24. So P sub B times square root of quantity 0.32 minus 0.24 square plus 0.24 square equals 18 Newton meter. So P sub B is 71.15 newtons. That's the smallest force, horizontal forces. Then at C, anywhere on the block, so from this figure, the longest distance between any 2 points would be distance AC. So the distance, the force at A should be in that direction. In that direction, the force at C would be in this direction opposite here. So that the moment would be in that sense. Now the distance AC, because these forces should be perpendicular to AC, is simply square root of 0.32 square plus 0.24 square. So P sub A times square root of 0.24 square plus 0.32 square equals 18. So P sub A equals P sub C equals 45 newtons. So that's it. Level 14. The frame ACD is hinged at A and D and is supported by a cable that passes through a ring at B and is attached to hooks at G and H. Knowing that the tension in the cable is 450 newtons, determine the moment about the diagonal AD of the force exerted on the frame by portion BH of the cable. So the objective is to compute the moment of the tension in BH about AD. So this is moment of a force, 3D force about an inclined axis AD. So it is equal to R from any point on the axis A or D, but the simpler is A, to the line of action of the force. So it's either B or H, but if you have AH, it's uh, longer vector. So we choose AB, RAB, because RAB is simply 0.5 I. Then BH is, since this is zero point 0.5, this is 0.875. 0.875 minus zero point 0.5 is 0.375 I. From B to H, you move to the right along X 0.375, then along Y upward 0.75, then along Z backward negative 0.75. Then lambda of AD is simply 1I minus 0.75 K, because that's the Z. So moment about AD is RAB cross tension BH cross the force. So RAB cross tension of the force BH dot lambda of AD. So RAB is just 0.5 I. I will not mention it anymore because we use scalar dipole product here. The result is a magnitude which is anticipated to be negative, because if this is A to D, your right thumb should be towards AD. The curling of your forefinger should be in this sense, but the force tension is in the opposite sense, so we expect negative moment here. But if you make it dA, then definitely your right thumb would be there, and it has the same sense as the sense of the moment of the tension. It will become positive, but we will just make it AD because that's the condition in the problem, regardless of the result, whether positive or negative moment. So tension BH is magnitude for 50, 0.375 I, 0.875 minus zero point 0.5, then plus 0.75 J minus 0.75 K, over square root of 0.375 square plus 0.75 square plus 0.75 square. So again, 0.375 is 0.875 x coordinate of H minus x coordinate of B. 0.875 minus zero point 0.5, then you rise by 0.75 to reach, then backward 0.75, so negative 0.75 K. So tension BH is 150I plus 300J minus 300K. Then lambda of AD is, A to D is 1I or I minus 0.75K divided by square root of 1 square plus 0.75 square. So simplifying, lambda of AD is 0.8I minus 0.6K. So substitute, we have 0.500 components of position vector RAB, then 150, 300, negative 300 for the force, then unit vector 0.80 along Y, then negative 0.6, then copy the elements of the first two columns, then evaluate this just like evaluating 3 by 3 determinant. So MAD is 0.5 times 300 times negative 0.6. That's negative 90, then 0, 0, minus 0, 0, 0. So as expected, moment in AD is negative 90 Newton meter. So that's the answer. Level 15, slider P can move along rod OA. An elastic cord PC is attached to the slider and to the vertical member BC. Knowing that the distance from O to P is 6 inches and that the tension in the cord is 3 pounds, determine the angle between the elastic cord and the rod OA, the projection on OA of the force exerted by cord PC at point P. So the second part can be easily answered after we obtain the angle between the elastic cord, where the tension is 3 pounds, and OA, or OP, that's the same, but we'll use OA. So this angle here. So the component or projection of this force on OA is simply 3 pounds times the cosine of that angle. So let's solve for the angle first. So the angle is obtained by getting the dot product of the unit vectors of PC and OA. So first, distance OA is square root of 12 square, along y 12 square, along z negative 6, so negative 6 quantity square or 6 square. So 12 negative 6 along z, then 12 upward, so that's distance OA equal to 18 inches. Since distance from O to P is given 6 inches, then we will compute delta OPX because we do not know the distance horizontally along X between O and P by similar triangles. So delta OPX as to 6 hypotenuse equals 12. For OA, it is 12, and length of OA or distance OA is 18. So delta OPX, which is equal to delta OPY also, because they have the same delta X for OA and delta Y for OA, which are 12 inches, so 4 inches. Then delta OPZ, which is expected negative, as to 6 equals negative 6. For OA, it's negative 6 over length of OA, 18 inches. So it is negative 2. So therefore, the vector form of OP or lambda of, so delta PCX is equal to 9 P to C. So C coordinate, X coordinate of C minus X coordinate of B. The X coordinate of B is 4. The X coordinate of C is 9. So 9 minus 4, delta OPX is 5. Delta PCY is 15 minus 4 because delta PCY is 15 minus 4, where 4 is delta OPY, 4 inches above the horizontal plane, and C is 15 inches above the horizontal plane. So therefore, C is 11 inches above P. That's why it is 11. Then delta PZ, this is 12. Z coordinate of C is 12 minus Z coordinate of P, negative 2. So 12 minus negative 2 is 14 inches. So therefore, lambda of CP or PC is 5I. Lambda of PC is 5I plus 11J plus 14K over square root of distance 5 square, 11 square plus 14 square. So simplifying, lambda of PC is 0.2704I, 0.5948J, 0.7570K. Then lambda of OP is 4I plus 4J minus 2K over square root of 4 square plus 4 square plus 2 square. So remember, square root of 4 square plus 4 square plus 2 square is 6. So 4 over 6 is 2/3 I plus 2/3 J minus 1/3 K. Then obtain the dot product to compute the angle between them. Lambda of PC dot lambda of OP is magnitude of CP, which is 1, magnitude of lambda of OP, because these are unit vectors, 1, cosine of the angle between them, application of that product. So therefore, lambda of PC dot lambda of OP equals cosine theta. So we have 0.2704 times 2/3 plus 0.5948 times 2/3 plus 0.757 times negative 1/3 equals cosine theta. So using your calculator, we can now compute theta, 71.07 degrees. Then the projection of the force on OA is equal to force, 3 pounds, times cosine of the angle between them, 71.07 degrees. So it is equal to 0.9732 pounds.